Hi everyone, my name is Li Yuanjing. In this video, my partner Andre Diaz and I are excited to introduce our software product, Ocular, a matrix collector to provide insightful data about the machine. This product can enhance observability and optimize the performance analysis for our client. Right now, let's begin. Before we start it, let's preview the content table that we will cover in this presentation real quick.
Ocular is a product that supports Windows operating system users by providing data about the machine being used, as well as information about the operating system and processes it is running. This includes metrics collection to promote observability, data storage to support high availability recovery, and real time data for efficient performance analysis. Ocular is compatible with Windows 10 or later versions. The metrics that Ocular will record will include the CPU, which will capture the processor type, the processor speed, which includes the current speed and maximum speed, as well as the process's count and uptime. For memory, Ocular will record the memory available, as well as the memory speed. For program and process information, Ocular will record running processes, which will include the name of the process ID, and the utilization of both the CPU and memory for that process. It will also record the process list history. Ocular stands out because of its versatile web-based user interface, offering convenient access to metrics through a web browser. This accessibility extends beyond traditional computers, allowing users to effortlessly monitor and analyze data on a diverse range of devices. Whether it be on a desktop or mobile device, Ocular's interface is accessible through any installed browser. This aspect maintains its functionality and performance, emphasizing adaptability and convenience for users navigating the complexities of real time data monitoring. All the data collected by Ocular will be stored locally and secured by authorized access to restrict unauthenticated users.
Ocular is a matrix collector system designed to gather and store system information in an SQLite database using Spring Boot application. The web-based interface enhances accessibility for users across different platforms. The system features a real-time dashboard with a graphic for in-depth data analysis. The application actively collects and transmits data to the SQLite database, establishing a robust foundation for information storage. When users access the interface, relevant data is dynamically fetched from the database through an API, providing real-time updates. The backend development is built in Java, leveraging the powerful Spring Boot framework to create RESTful APIs. These APIs act as a bridge for interaction with the designed SQLite database. For testing, it includes the implementation of the JUnit tests, ensuring issue identification during development, contributing to an accelerated development timeline. This comprehensive approach aligns with industry best practice, guarantee a scalable foundation for the Ocular system. Here is the relationship diagram for our software. As you see right here, there are three main components: web-based UI, metric collector, and SQLite database. The database connection is established between the Ocular and the SQLite database. The Ocular acts as an intermediary that communicates with the database to retrieve and store data. In other words, the API allows the UI to send a request to the backend application, and the application processes this request, performs necessary business logic, interacts with the database, and sends back a response. The UI sends a request to the collector, and the collector retrieves the necessary data from the database processes if it is required, and sends it back to the UI for displaying. Development methodology. Ocular adopts the agile development approach, breaking the project into two epics: backend and user application. These epics are subdivided into user stories covering aspects like database, user applications, and metrics collection from client machine. Debugging is performed at each development stage, learning from errors and implementing improvements to enhance Ocular continually. The Agile approach focuses on delivering quality software promptly, providing time for testing and debugging. It emphasizes gathering feedback to ensure iterative refinements, promoting adaptability and responsiveness throughout the development lifecycle. Ocular development relies on Microsoft Windows 10 or later version for customer environments, and Java 17, Spring Boot, and JUnit for the development team. All the early Windows versions such as Windows 7, Windows 8, and XP are not supported. The front-end employs JavaScript to fetch data, HTML5 and CSS3 to design web pages, while the database is SQLite. GitHub issues track defects, and Visual Code 2022 on Windows 10 is the chosen code editor. Maven serves as a build tool, offering efficient compilation, testing, and packaging into a jar file. It has the pom.xml file that defines all the project components and dependencies and is needed to build a Maven project. Release notes on GitHub keep users informed of new features and bug fixes. It helps us to track issues efficiently. The release process includes providing release notes via the GitHub repository and documenting new features and bug fixes transparently for users.
Is to provide users with useful information for monitoring system performance. The metrics included will cover CPU, memory, and running processes. These metrics will be gathered using a variety of libraries and tools, including the following: operating system MXBean from Java, management factory from Java, memory MXBean also from Java, and Windows management instrumentation. Java will be used to read metrics from the client machine, which will then be stored in the SQLite database. The runtime.getRuntime.execute command will be used to pass command line queries from the Java environment to fetch metrics from the client machine. The polling frequency will be every 30 seconds, and over time, as the collected data grows, some of it will be trimmed off. Spring Boot provides a comprehensive logging framework built on top of the Java util logging libraries called SLF4J. SLF4J offers multiple levels of security like error, debug, trace, warning, and info, and will be utilized from the actual collection point to the data storage endpoint to assist with debugging and ensure proper operation of Ocular. We have chosen to use SQLite 3 to store the system metrics. Several reasons led to this decision. First, it's easy to use. There is no complex configuration for SQLite 3 compared to other relational databases on the market. Transaction support. SQLite 3 supports ACID, which stands for atomicity, consistency, isolation, and durability. Third, SQLite 3 is suitable for our project. SQLite is suitable for our project because it is not heavy, which means that it will not consume unnecessary resources compared to other relational databases on the market. Considering scalability and flexibility, we chose to use multiple tables for our database. This allows us to organize the data by device type. Next, let's talk about Ocular's database schema. The database for Ocular will have 4 tables for CPU, memory, processes, and users. The CPU memory, and processes table will use the time at which the data is collected as the primary key, allowing Ocular to maintain history. User data and metrics will be sanitized and verified prior to being set to the database. Now let's look at some of the tables that Ocular will use. For starters, we have the CPU data table. Now, the CPU data table will have the date time at which the CPU metrics are collected, and that will be the primary key. It will also include a column for CPU utilization, a column for CPU speed, another column for CPU uptime, another one for CPU processes, and the last column for each CPU data row will be CPU threads. For the memory table, we will also be using the date and time at which the data is collected as the primary key. The memory table will also have columns for memory usage, memory speed, and memory available. For the process table, we will again be using the date and time at which the data is collected as the primary key. For columns, the process table will include a column for process name, a column for the process ID, another column for the CPU percent used, and the last column will be for the memory percent used. For the users table, we will be recording the username. There will be a column for the password, another column for the admin privileges, and the last column will be for the user's email.
Right now, let's look at what a UI design looks like. The user interface will display the user account information and the matrix information. As you see, there are three main components right here: the basic CPU and memory gauge, CPU and memory graph, and the processes. Right now, let's look at what the UI design looks like for Ocular. The UI will display the user account information and the matrix information. There are three main components right here: the basic CPU and memory gauge, CPU and memory graph, and the processes. In Ocular's interface, CPU and memory usage is presented through a half-circle gauge resembling a car speedometer. The gauge is color-coded. Green signifies optimal usage between 0 to 50%. Yellow indicates moderate usage between 50 to 80%, and red alerts users to heavy usage between 80 to 99%. This usual design enables users to swiftly assess system activity, providing a clear and at-a-glance understanding of performance levels. The CPU and memory graph will display the detailed information about the CPU and memory, such as CPU type, utilization, current speed, max speed, and uptime. For the memory, it will include RAM total usage, in-use usage, and cache and buffer usage. For the processes, it displays each process hardware usage, including PID, name, CPU and memory, and RAM usage. The order follows from high usage to low usage. Package and distribution. Ocular employs Maven as the build tool for package build and distribution. It will work with Spring Boot without any additional complexity to our build process, since Maven takes care of that for us. Maven compiles source code, conducts unit tests, and packages the application into an executable jar file. This streamlined process enhances installation and facilitates efficient deployment. Installation. Ocular prioritizes compatibility with the popular browsers to ensure a smooth user experience. For accessing Ocular's web-based interface, users need to a modern web browser like a Google Chrome, Firefox, Safari, or Microsoft Edge. A stable internet connection is essential for seamless application accesses.
In this project, the most significant risk revolves around time and team size. Designing and completing a business product in less than 3 months with 2 members on the team poses a considerable time constraint and massive workload to each member. A typical software development timeline averages between 4 to 9 months. To meet this deadline, team members may need to sacrifice personal time to propel the progress forward. While we assume that the team already possesses the necessary skills for the project development, adapting these technical skills to the new project environment will also be a crucial factor. Ocular will use a couple of dependencies. The first one is Spring Boot Starter for web. This includes everything needed to build a web-based application using the Spring Boot Web MVC, which stands for Model View Controller. We will also need Spring Boot Starter for Data, JPA. This simplifies the data access using the Java Persistence API. We will also need the SQLite JBDC driver, which allows the Spring Boot application to interact with a SQLite database. Spring Boot Starter for testing will be useful for writing unit tests and integration tests. These unit and integration tests will allow us to continually test our code as it's being modified to ensure that it does not break any features currently in place. We will also be using Maven Central's repository to ensure that the latest version of these dependencies are used during the development process.
Thank you for watching. If you have any questions, feel free to reach out to us. For more detailed information, you can explore our design document. Thank you.